Calculating precision, recall an F-score in one pass, Python. Accuracy, precision, recall and F-score are measures of a system quality in machine learning systems. It depends on a confusion matrix of true/false positives/negatives. Given a binary classification task, I have tried the following to get a function that returns accuracy, precision, recall and F-score. But it seems like I have redundantly looped through the dataset 4 times to get the true/false positives/negatives. Also, the multiple try excepts to catch the zero division error is a little redundant. So what is the Pythonic way to get the counts of the true/false positives/negatives without multiple loops through the dataset? How do I Pythonically catch the zero division error without the multiple try excepts? I could also do the following to count the true/false positives/negatives in one loop, but is there an alternative way without the multiple if?
What is the Pythonic way to get the counts of the true/false positives/negatives without multiple loops through the dataset? I would use a collections.counter. Roughly what you're doing with all of the ifs, you should be using else, as your conditions are mutually exclusive at the end. Then for example true_pos equals counts 1, 1. How do I Pythonically catch the zero division error without the multiple try excepts? For a start, you should, almost, never use a bare except column. If you're catching zero division errors, then write except zero division error. You could also consider a look before you leap approach, checking whether the denominator is 0 before trying the division, for example.
This is a pretty natural use case for the bitarray package. There's some type conversion overhead, but after that, the bitwise operations are much faster. For 100 instances, tinyit on my PC gives 0.036 for your method and 0.017 using bitarray at 1000 passes. For 1000 instances, it goes to 0.291 and 0.093. For 10,000, 3.177 and 0.863. You get the idea. It scales pretty well, using no loops, and doesn't have to store a large intermediate representation building a temporary list of tuples in zip. Depending on your needs, there are several libraries that will calculate precision, recall, F-score, etc. One that I have used is scikit-learn. Assuming that you have aligned lists of actual and predicted values, then it is as simple as one of the advantages of using this library is that different flavors of metrics, such as micro-averaging, macro-averaging, weighted, binary, etc., come free out of the box.
If you want to support the channel, please consider subscribing.